that is the essential time we get to circle. Mercury opens at the vanguard. State-of-the-art, our Sun framework lies in Mercury. A little uninhabited planet enveloped by a web. State-of-the-art craftsmanship, interest, and secret. At a simple look, nothing appears significant about this planet yet. Ongoing investigations using NASA have uncovered a couple of astonishing discoveries about Mercury that no one anticipated. Most recent, the thought-blowing discoveries, along with records from the James Webb Telescope, have ignited contention in the scientific community, with many pointing to the possibility of ultramodern extraterrestrial species stowing away on the world. In the midst of the tumultuous discoveries and strange conspiracies, another theory is emerging within the scientific network. It is the end-all strategy to strip Mercury of its state-of-the-art covers and screen its dark secrets and methods unequivocally. What incredible secrets and methods have researchers found about Mercury, and what current plans does the scientific community have for this secretive cosmic neighbor? Join us in this video as the Webb Telescope finally found what NASA had been stowing away on Mercury, all close by our solar system. It is more than just an inert body. Most recent planet swinging in the vast mirror round every day, the 8 planets that make up this puzzling ring device have dazzling abilities, but it's Mercury that has remained overlooked, despite its fascinating qualities. Though planets like Jupiter and Mars have captured the spotlight with their incredible significance, another intriguing planetary body that seems to have gotten lost in the crowd is Mercury. Mercury is the planet that lies at the very top of the list in terms of proximity to the Sun. Its distance from the Sun is a mere 58 million kilometers. Compared to Earth's 150 million kilometers, Mercury is also much smaller compared to Earth, measuring just 30,000 miles in diameter. Because of its small size, Mercury is the fastest planet to complete its revolution around the Sun, at an incredible speed of 47 kilometers per second. The planet completes a full revolution in only 59 days. In other words, 1 year on Mercury is just 88 Earth days. Mercury's small size and high speed are just a few of its captivating qualities. From a distance, at the astronomical scale, it even looks like a relatively unimportant planet. The small planet has always been captivating to the scientific community, but for some reason, it hasn't garnered the same attention as its larger counterparts. The first recorded observation of Mercury was in 265 BC, with early astronomers like Hipparchus and Ptolemy studying it as early as the 2nd century. However, the scientific community could only study fragments and pieces of information through the limited telescopic technology available at the time. It wasn't until the 1960s that substantial information about Mercury came to light, thanks to the efforts of NASA. Several years ago, NASA released the first real photographs of Mercury to the public. These larger-than-life images showed Mercury as a divine example of state-of-the-art excellence and complexity. However, despite cutting-edge designs and technological efforts to explore Mercury, scientists still faced difficulties. Researchers struggled to study Mercury as effectively as they could other planets due to its proximity to the Sun. The Sun's harsh rays and bright light can damage optical instruments like telescopes when they observe Mercury from too far away. As a result, scientists can only observe the tiny planet for a few minutes at a time to avoid damage to their equipment. Even the James Webb Telescope can't directly observe Mercury due to its closeness to the Sun. It is truly baffling how this tiny, nearby planet is harder to investigate than the more distant planets. Moreover, the temperature and gravitational pull from the Sun pose a serious challenge for space probes trying to study Mercury. Sending a probe to Mercury is more like a suicide mission than a celestial task. The probe must adjust to extreme temperature fluctuations, weather conditions, and gravitational forces, making it a perilous endeavor. It may surprise you to know that Mercury blasts across the Sun at an incredible speed, about 30 kilometers per second. This time-breaking speed makes it the fastest orbiting planet in our solar system. This also presents a significant challenge for spacecraft attempting to survey the planet or land on its surface. So far, only a few space missions have had Mercury as their target: the Mariner 10, launched on November 3, 1973, and the Messenger, launched on August 3, 2004. These two missions were the brainchild of NASA and provided most of the valuable data we have about Mercury today. The Mariner 10 spacecraft performed 3 flybys, revealing the rugged, crater-filled surface of Mercury and shedding light on its magnetic field. If you're wondering how this spacecraft was equipped, it had 2 telescopes, spectrometers, a magnetometer, and a plasma analyzer. NASA aimed to gather as much information as possible from Mariner 10's visit to Mercury. As luck would have it, the spacecraft successfully made its way to the tiny, fast planet. As Mariner 10 approached Mercury, scientists were astonished to observe the tumultuous surface, pocked with craters and ridges, much like our moon. The photographs from Mariner were awe-inspiring, revealing Mercury to be unlike anything scientists had expected. In addition to the rugged planetary surface, the spacecraft also detected a surprisingly strong magnetic field. In total, Mariner captured 2,700 images of Mercury, providing scientists with an unprecedented view of the planet. The second flyby of Mariner 10 took place on September 21, 1974, during which it captured images of the southern polar region. The final flyby occurred on March 19, 1975, after which the spacecraft stopped transmitting data to Earth. Subsequent analyses revealed that the spacecraft had depleted its fuel, rendering it incapable of making further rounds. The incredible photographs sent back by Mariner 10 were analyzed 30 years later, while NASA's Messenger spacecraft took the next step towards studying the nearby planet. Unlike its predecessor, Messenger didn't just perform flybys, it also managed to orbit the planet. This allowed scientists to gather even more detailed data. Equipped with amazing photos, NASA sought even deeper insights into the atmospheric conditions and chemical composition of Mercury. Planet NASA likewise needed to notice the planet's attractive region as appropriately as dive deep into its geologic history and planetary center, as you would depend on the Courier test, which became stacked with every one of the fundamental gadgets it may need for this momentous errand. Curiously, the test made 3 circles around Mercury, during which period it took around 200,000 photos of the current day on the planet. These pics were specific because, as opposed to the Sailor Challenge, they included each side of the present planet. During the Courier mission, the test managed to go into Mercury's orbit, floating at around 250 kilometers above the planet's surface. This vicinity enabled the test to take pictures of both the light and dark aspects of Mercury. Subsequent to diving deep into the pics and contrasting them with insights from the rocket's instruments, NASA found out that our costly sister planet had unusually high concentrations of calcium and magnesium on its night side. Additionally, the magnetic field of the planet appeared to be oddly contorted, seeming more strong and intense in the northern regions. This strange pattern in the magnetic field astounded researchers for many years, until deep exploration was conducted to uncover the situation behind this peculiarity. You notice Mercury's odd and remarkable magnetic field is a result of how the planet forms its core. Magnetic fields on planets are created from the reactions that pass on in their cores. Take Earth for example, the deepest parts of the Earth's core include liquid iron, and as the inner layer of this iron acclimates to solid, the fluid iron inside the core causes a magnetic field. In other words, greater and greater cast iron is formed in our planet's core every day. As fluid iron cools and solidifies to form stable iron, it interacts with the surrounding fluid iron. As this occurs, the Earth twirls around its axis, and a convective shape is created. Eventually, successful electric currents are generated, producing a huge magnetic field that stretches into space. This is the authentic mode of operation for the Earth and the way its magnetic field is generated. For Mercury, however, it is a particular ball game. Mercury's mode of current activity is unusual to such an extent that it left scientists totally overwhelmed. In recent studies, led by researchers from the University of California, Los Angeles, it was discovered that iron transitions from fluid to solid at the core's outer limit. This is extremely distinct from Earth, where the transformation from fluid to solid happens at the core's inner limit. One researcher had this to say: "We had figured out how the Earth functions, and Mercury is another terrestrial rocky planet with an iron core, so we thought it might work the same way. However, it doesn't work the same way. It resembles a snowstorm, where the snow is falling at the apex of the cloud, in the center of the cloud, and at the bottom of the cloud. Looking at Mercury's magnetic field suggests that iron is snowing throughout this liquid, which is controlling Mercury's magnetic field. Further research, confirmed by data from NASA's Courier mission, revealed an astonishing discovery. This led researchers to agree that planets can have more than one way of generating magnetic fields. Despite the fact that Mercury and Earth have similar components like sulfur and iron, certain aberrations in these two planets can cause dramatic variations, as seen in their magnetic fields. However, the difference between Earth and Mercury goes beyond just the magnetic field. You'll notice there are various other anomalies that this celestial body does not seem to follow. For instance, scientists were baffled to find that temperatures on Mercury can push over 430 degrees Celsius during the day, but drop to as low as -70 degrees Celsius at night. This baffling situation is a result of Mercury's lack of atmosphere. Unlike Earth, Mercury has a thin exosphere, which is just made up of particles shot off its surface by the impact of meteoroids and solar winds. Scientists acknowledge that because Mercury is excessively hot, something that could form a proper ecosystem would quickly be dissipated into space. Moreover, because it lacks atmospheric factors, the aspect of Mercury that faces the Sun gets impacted with intense heat. Here's where it gets even more astonishing: one complete day on Mercury is almost twice as long as its year. While 365 days on Earth equals about 88 Earth days, one day on Mercury essentially lasts around 176 Earth days. This means one side of Mercury gets consistently bombarded with extreme heat and sunlight, while the night side is much cooler. These two factors, its extreme temperatures and longer days, are the main explanations behind the drastic temperature changes. The extraordinary temperatures on Mercury have sparked wild theories in the scientific community. Having a magnetic field and a rocky soil structure makes Mercury a potentially inhabitable planet, but the extreme temperatures make life on Mercury almost impossible. Still, some controversial aspects of this mysterious planet have left many wondering if there's any possibility of finding life there. Mercury and this is starting questions like, consider the possibility that Mercury is really inhabitable, and on the off chance that it is, what feasible ways of life structures should exist on the planet? Up until this point, the floor of present-day Mercury has been very interesting, similar to our Moon. The planet appears to have several impact craters, much like the Moon, which has long been filled with contentions and paranoid notions about extraterrestrial beings. Many argue about the possibility of extraterrestrial moon bases due to its surprisingly large number of craters. Some of these craters take puzzling shapes, like arches. Despite the lack of evidence, many have speculated about the presence of ultramodern species on Mercury, suggesting that some craters may have been caused by shuttles, such as NASA's Messenger spacecraft, which created a huge crater when it collided with Mercury's surface on April 30, 2015. Today, there are countless craters, cracks, edges, and even lava eruptions. So, consider the possibility that these various craters were caused by similar extraterrestrial shuttles or alien activity. There are other astounding facts about Mercury that have fueled conspiracy theories. For instance, the ice water stores located inside the craters at the planet's north and south poles. Recent studies by the Planetary Exploration Institute suggest that the planet's north pole could have the right conditions for extreme storms, which function similarly to those on Earth, only they are hidden beneath the planet's surface. This conclusion was drawn from photos taken by NASA's Messenger spacecraft, which were turned into a map using this data. Researchers noticed that there are certain salt ice sheets on the planet that are filled with unstable mixtures that could potentially support life. Thus, even within the deadly proximity to the Sun, scientists agree that there is a possibility of extraterrestrial creatures or ultramodern biolife existing on Mercury if we dig deep enough. One of the greatest achievements of NASA's Messenger spacecraft was creating a map of Mercury, capturing all the craters and bowls on the planet's surface. This gave NASA researchers the opportunity to study the planet's geography in depth. But even more importantly, the spacecraft also revealed that Mercury has a surface composition of 46% oxygen, 12% magnesium, 26% silicon, 7% aluminum, and 4% calcium. Researchers also found that the planet has an unusually high presence of sulfur but low levels of iron. This discovery sparked debates within the scientific community, as it sets Mercury apart from the other planets in our solar system. Planets in the solar system are generally recognized to have more iron than sulfur, especially in their cores. Seeing a planet that does not follow this standard intrigued scientists and sparked increased interest in Mercury. Recently, researchers also noted something surprising about the planet: it has a distinct dusty ring around it. This sparked further debates, as many scientists believe Mercury is too small to have a planetary ring. In our entire solar system, only Jupiter and Saturn are known for their rings. Saturn's rings are massive and easily visible from Earth, consisting of billions of pieces of debris, ranging from small to enormous. The substances that make up Saturn's rings include water ice and rocky material. Researchers believe these rings formed during the early days of our solar system, and the massive size of Saturn and Jupiter allowed them to pull in the material needed to form such rings. Saturn is about 10 times the diameter of Earth, and Jupiter, nearly 12 times the diameter of Earth, has attracted around 95 moons, forming its own miniature ring system. Given the immense size of Saturn and Jupiter, it is understandable how these planets were able to attract vast amounts of cosmic material to form their rings. However, this raises the question: how does Mercury, the smallest planet in our solar system, form its own rings? For reference, Mercury's dust ring is about 9 million miles wide. Researchers are still uncertain about how these rings were formed, but many speculate that they may come from asteroids, which could have impacted the planet at some point in the past. A group of researchers led by Dr. Peter P., an associate at NASA, suggested that this theory could be correct. According to him, it is not uncommon for objects to continually collide with planets like Mercury, which lacks a significant atmosphere. It is plausible that these collisions could have launched debris that eventually formed the visible dust ring we see today. Other scientists in the academic community seem to agree, suggesting that the constant bombardment of Mercury's surface by meteorites and other disasters may have contributed to its small size and thin mantle. Mercury's outer shell, also called the crust and mantle, is much thinner compared to Earth. It is only about 250 miles thick, whereas its core makes up around 85% of the planet's volume. Many leading minds speculate that Mercury must have experienced catastrophic events that stripped it of its outer layers, leaving it in the state we see today. Despite all these theories and speculations, there is still a need for NASA and other research organizations to dig deeper into the mysteries of Mercury to answer all of its current-day questions.